All right, part two of veritasium response video. Yeah, we'll call it a response video. Anyway, so yes, just continuing. I'll get to it. So we're at the point where he's talking about Bohr, okay, who was a defender of Wu. He didn't think the universe was comprehensible. I mean, you might as well just say he implied a belief in some sort of God bullshit, frankly, some creative thing, because it's all way too complicated for us to understand. So therefore, we must believe it was created by mystical mechanisms, something like that. Anyway, it just reeks of it.
You go.
And what he wants to do is, he says there's something fishy about something being discrete. That seems to be the new ambiguous weirdo lesson of the new quantum of action.
So discrete is something that this Bohr didn't like, anything that's mechanical, frankly. So he had to break something mechanical. All right, but the idea of an orbiting electron, again, I'm just saying that this one bothered me when I was a little kid. I mean, as soon as they told me that there's an electron orbiting, I'm saying it's got to be orbiting in the universe where all this stuff, just like I'm in a universe, and there's stuff that hits me, and I know there's stuff hitting electrons, so why would I think they could do this? And then how could they possibly share an electron that moves from the opposite side? I mean, it's like having there's no connection, right? I mean, if the electron's on the opposite side of this atom and there's two protons looking at each other, why wouldn't they just repel and get the hell away? How are they going to be bound by some figure eight nonsense? All of that made no sense at all.
Bohr realizes that as the electron goes around the nucleus, it has an angular momentum. Mass times velocity.
And that's it. That's all the angular momentum is mass and velocity. Okay, so again, I don't know. They sit there and say the radius. Now, what's the radius going to be even measured in, right? If you measure it in meters, then its angular momentum is going to decrease because it's a point something number. It's the electron radius from the nucleus is some 0.000000. So somehow you'd turn the energy of the electron into nothing. So that doesn't even make sense. So it obviously must be in some other unit.
Velocity times radius. So angular momentum has the same units as action.
The same bullshit. So again, and there's just no reason for any of this. The stuff in the other color letters is the stuff you don't need. The only thing that matters in the universe is mass and velocity. Mass and velocity. Mass and velocity. Mass and velocity. It's all just, if you want to ask an important question about something, you just say, how heavy is it and how fast is it moving? That's it. That's all the information you need to know.
And so what he decides to do is discretize the orbital angular momentum for no good reason. He says, let me slap that on and say angular momentum of the electron can only be in 1 unit, 2 units, 3 units of the same quantity h. And because it's talking about motion in a circle, the factors 2 pi come in, so it's really...
So you're just basically saying that you're adding velocity. Let's say if you had an orbital and you added velocity to an electron. Well, it would have to jump to a higher orbit because now it's got a faster velocity. So that part makes sense, and it stays with this idea of the quantum of energy. So obviously, if an electron is moving 10% the speed of light, then it's moving 20% the speed of light, then 30% the speed of light, you'd understand it have a different relationship to the proton. But again, you don't need orbits to make this argument. You can just say that it's just a fact that in a noisy universe, electrons and protons might have a hard time actually crashing into each other because of the constant motion they're moving side to side, and they're evading each other's capacity to orient themselves to this extra pressure on the outside. And frankly, my simulation duplicates some of that, okay? Because there's not only the energy you're moving into and away from, there's the energy coming this way. And obviously, you're going really fast, you're evading this energy as well as the energy from behind. So, I mean, it gets a little bit complicated, but the simple point is obviously if the velocity was in quanta, And that's the whole argument here, is that there's a quantum of force. It hits an electron. It gives it a discrete momentum, a discrete addition to its velocity or subtraction from its velocity. So if it's opposing an electron, it's going to take away from its velocity. If it's going in the same direction as the electron, it's going to increase the electron's velocity by a quantized amount, by a known complete amount, because all of the forces are the same little bits moving the same little speed.
NH over 2 pi, what we now call NH bar.
This comes out of nowhere. There seems like absolutely no good reason why angular momentum should be quantized.
Right, so it's not. Okay, so it's the wrong, but you could argue it's about momentum because it's about movement. All right, and all you're saying is that something oscillating is moving. Okay, it's not doing a circle, but clearly how much it oscillates will dictate how close it can be to a proton, for example. The more motion it has, the less the force from the proton can affect it.
But by doing it, Bohr finds the correct energy levels of the hydrogen atom. When an electron...
So these are the ability for the distance from the electron to the proton. So the whole point saying hydrogen atom, when they're not even going to tell us what hydrogen you're talking about, right? Is it molecular hydrogen when you have two hydrogen atoms stuck to each other? Is it just a single hydrogen like a proton and an electron, which he illustrated? Or the other version of hydrogen they call a single proton? So you have deuterium, you have all these different things that are supposed to be the same thing, and they really... I would argue that hydrogen is what neutrons decay into. A neutron is hydrogen with the electron and proton really close to each other. And the further away it gets in these different forms of hydrogen. And so really you're just saying that when you have a hydrogen atom, you can have one that's wobbling a lot, or you can have one that's wobbling a little. The less wobble, the tighter it is, the more wobble, the further away the electron is from the proton, and those are the orbits.
Jumps from a higher orbit to a lower one.
And it's not really jumping to lower ones. It has to be pushed into lower ones. So again, it's a push-averse. You know, they think it's a pull-averse. It's a push-averse. So you're pushing something that's far apart close, rather than pushing something that's close far apart. When you expand it, you create more energy. When you reduce it, when you compress it, you use energy.
The energy difference is given off as a photon of a...
So it's exactly the opposite. When you go the other way, you're giving off the photon. When you're going in, you're consuming the photon. So they have that backwards.
Particular color of light, exactly reproducing the hydrogen spectrum.
Right, but it doesn't work for any other atom. So let's just understand, they can't use the same theory to predict the other atoms. First, because they're more complicated, obviously, but they just don't have any model that fits. So I'm just saying it's not the right answer because it only works for hydrogen. So you're missing some detail.
And that was a pretty startling thing to have fall out. I think that really was compelling. It takes some quantity with units of action and apply some, again, kind of ad hoc discretization or quantization to it.
Now, although it worked spectacularly well, no one could make...
So it's not spectacularly well. So, I mean, these are this is the hyperbole, just to, exaggerate part of the propaganda game.
Sense of it.
And again, it can be explained in lots of different ways that you're saying. What you're just explaining is the fact that the energy appears to be in chunks, and that you can only add energy in chunks, amounts. And that perfectly fits with, again, a theory that just says a photon is made out of chunks, light quanta, as Einstein would say.
That is, until 11 years later. For his PhD, Louis de Broglie was contemplating the recent discoveries in physics.
So this was just horrible. I mean, the the silly notion that because photons look like a wave will turn matter into waves too. And it's just ridiculous. Electrons are not waving in any respect whatsoever. They're oscillating when they're stuck in matter, and when they're flying through space, they're obviously affected by all kinds of field perturbation. So any influence in the field is always going to take an electron's attention. So if I place an electron in the universe, the electron will automatically start heading in a direction because the universe is always going to look charged. There's going to be somewhere there's going to be more proton than electron. It's going to be looking at the universe, and it'll see places that have more electron than proton, and it's going to head towards the more place with more proton. And as it gets closer and closer, then it's going to run into this problem, where depending on how close this hand is to this hand, I can completely obscure this proton. So this proton is moving, but you can't see it because the electron's closer to you. And it's not until I move the electron back here that now you can see the glimmer of the proton. Yeah, that kind of thing. So as the electron heads for something that looked to it like it was more proton, it's going to all of a sudden be obscured because now it's getting closer to the electron and it's seeing less of the proton. I mean, it's another way of looking at this, is looking at it as if electrons are in a field, okay, and they react to it in this sense of there being a pressure pushing them and a place where there's no pressure pushing them from the face. So it's a place where there's wind and no wind, and they tend to go where there's no wind.
And his big insight was that if light could be both a wave and a particle, then maybe matter particles could also be waves.
So guys, it's just silly. And what is the mechanism, right, to do this? Look at the way they draw this thing, as if it's actually moving through space doing this. How exactly would it be doing that? What is telling it to do it? It's not a snake. It doesn't have muscles. So the external environment has to be doing it somehow. And then we're back to an ether or something. How the fuck is it doing this? What's the mechanism to do this? I can't do that.
He proposed that everything, electrons, basketballs, people, absolutely...
Oh, it's just ridiculous. To say people have a frequency. I mean, it's so ridiculously overdone, overstated nonsense. To say, I mean, even to say electrons are wavicles is idiotic. But I mean, to take the atom structure and then try to say the big universe is atoms, it's not. We're the byproduct of atoms, just like we're made out of living cells. We're not cells. We're made out of living cells. The rules for cells and the rules for this big organism with a brain are completely different rules. Don't exactly know why I did that. Anyway, continuing.
Everything has a wavelength. And he defined this wavelength analogously to light, as Planck's constant divided by the particle's momentum, or mass times velocity.
And I don't know what use that relationship would be. I mean, the mass and the velocity clearly has a meaning. The idea that there's a constant, why would I divide it into the constant? I might as well just to multiply it by the constant. But regardless, doesn't matter.
Now, if an electron is a wave, the only way it could stay bound to a nucleus in an atom is if it exists as a standing...
I guess the point to state is the idea that they're saying momentum is created by frequency. And again, I've made that argument over and over. The frequency is tricking you. It's just applying the force more quickly. It's causing the thing to accelerate quicker than the friction can bind it. So it's defeating the drag that could exist by accelerating quickly, but it's not more energy.
Wave. That requires that a whole number of wavelengths fit around the circumference of the orbit. You could have one wavelength or two wavelengths.
You could do that same description without any orbit. So you could just say if the electron was in this position, it could oscillate in that position. And there's no need to have it orbiting. Technical issues and such. Anyway, back.
Is a wave. The only way it could stay bound to a nucleus in an atom is if it exists as a standing wave. That requires that a whole number of wavelengths fit around the circumference of the orbit. You could have one wavelength or two wavelengths or three and so on. So the circumference 2 pi r must be equal to some multiple n times the wavelength. We can sub in de Broglie's expression for the wavelength to get that 2 pi r equals nh over mv. But we can rearrange this to get that mvr, the angular momentum, is equal to nh over 2 pi.
So again, it's always just relationship. So again, the fact that the electrons on the surface of a piece of glass, for example, are in a condition that is a reflection of how dense the glass is. Not a surprise.
That is precisely Bohr's quantized angular momentum condition. But now we have a good physical reason why it's quantized, because electrons are waves and they must exist.
So they're not waves, and all you're doing is giving them the key word you used before was momentum. If you increase their momentum, you're going to change what position they're going to be in relative to the proton. So that's all you're saying, is that you're changing their position relative to the proton by giving them more or less velocity. We know their mass isn't changing, so it's just about their velocity. And the force is what gives them velocity. Suppose. Oh, Jesus, I can't everything keeps wrong buttoning somehow.
As standing waves to be bound in atoms.
Because they want to have constructive interference of a stable orbit.
So this constructive, destructive, there's no such thing. The double slit proves that whole nonsense isn't real. Okay, there's nothing, no photons destroyed. There's no, the photon is being bent into some other condition or going in some other direction. None of that's happening. They're traveling, the bits of force are traveling dead straight lines. That's what all of the geometry is, dead straight lines. So again, just bullshit.
Back. That's pretty good. You get a dissertation out of that. That's pretty good.
It is this wave nature of quantum objects that means they no longer have a single path through space.
So again, just nonsense. So they're basically telling you, okay, that atoms aren't really atoms. They're not things in positions, and they can't make machines because the machines are constantly doing all of this because of this orbiting crap. I mean, it's just nonsense. Nothing's confused about where it is in space. It's so revoltingly silly.
Instead, they must explore all possible paths.
Again, nonsense. With what tools do they do this exploration? I mean, it's just such an extraordinarily complex thing. I mean, this is more complicated. I mean, we have to use all of our best science to create penetrating radars and different things. It's very complicated and difficult. And they're saying, oh yes, this is some innate function that the elemental universe has, and somehow, again, no biological organism can exploit it. So, two-slit experiment. So here we go. The bullshit.
Now, I have thought about and taught the double slit experiment.
Yeah, taught, he says. Yeah, I've taught. You've taught, and what you do is show something that doesn't actually happen with actual photons, or electrons for that matter. Electrons are not put through two slits. It would be irrational to do it. Just think about it. It's a charged object. How can I put it through an obstruction made out of electrons and protons? How could I possibly send a charged object through a slit unless I controlled exactly what the charge on the slit was? I mean, there's no way a charged object could neutrally go through a slit because of charge. I mean, this is just such ridiculous nonsense.
Hundreds of times without fully realizing this implication.
So this isn't the double slit in light, okay? This is water waves. There's no double maxima, quite obviously, and there's no envelope pattern. So it's nothing like the double slit in photons. The double slit in photons with open slits. Again, if you close the slits, you're killing two of the point sources, right? So if the 2 point sources are so close, the slits, that there's no wavelength of difference, and you can't draw lines anywhere where there's a wavelength of difference. So obviously there can't be any on-off pattern because you can't draw that wavelength of difference. But if you open the slit and make a 2-slit experiment, this is not the pattern you're going to get. You're going to get a central maxima that's twice the size, and it's going to have nodes inside of it, an odd number of nodes, always an odd number, because it's basically 2 of the other nodes smashed together. So if there's 3 in the regular small nodes, then there's going to be 7. 3 plus 3 is 6. Well, I mean 5, sorry. 1 less than twice the node size.
In the double slit experiment, I feel like the mental thing that I'm doing in my head is like, okay, well, the beam is not perfectly straight, and of course it's going to intersect both of those slits.
So what does that mean? It's going to intersect both of those slits? What does that even mean? It's going to intersect the surfaces. The photons are much smaller than the system. You've already said that. The wavelength is defining the size of the photon, so you know it's a lot smaller than the fucking opening. So what are you pretending that the same photon can cover that huge distance of both slits? It can't. So it's just nonsense.
They're really close together, you know? But then I heard this story about a professor.
So this is like, so I heard some story, and then he doesn't even tell us what the story is, and then the story apparently is Feynman, and apparently it's one of Feynman's fake stories. So what's it? So he heard a story that he admits isn't true. So why animate a story you know isn't true?
Teaching the double slit experiment, and it makes everything so clear.
I mean, hilarious, right? All right, so here's the classic crap drawing, right, of crap waves and crap lumpy lines. So this is Feynman's drawing, frankly. It's just as bad as. So it has all the features that I have pointed out over and over. So go to debatephysics.com. And there's a video that says double slit on it. Watch that video because it explains all of these flaws. Now I have a ton of other videos if you search my channel. But right here where they draw these 2 lumps, the slits are less than 1 millimeter apart. The 2 lumps are not going to spread, okay? They're not fringing. They're not scattering. They're not going to be fringed. They're going straight. The light's going straight through the 2 slits and going straight across. If they're not creating a fringe pattern, then the pattern is 1 millimeter apart. The 2 lumps would be so close to each other that you couldn't see the difference, because one of the fringe patterns, would only be 1 millimeter shifted from the other fringe pattern. So you're looking at a pattern on the wall that might be a foot across, and you're going to see 1 millimeter of difference? No chance. So this whole part of the drawing is just a lie. It wouldn't happen. This slop is supposed to be the double slit pattern. So if you watch the first video, I showed a clear drawing. I could pop that up. What the hell, right? I believe I can. Does that work? Yeah, that works. And I just have to move this over for now. So, yes, so you can see the double slit, okay, creates this complex pattern. All right, it's not a nothing pattern. It's got 2 patterns built into it. And the clear argument is the only thing different between the single slit here and a single slit here, and I drag them into each other, is I create this new distance between the 2 outside surfaces. That's the new huge difference. And that's the one creating the little nodes, because the bigger the distance, the more wavelengths, the more geometric possibilities of having an on and off, in phase, out of phase. So it's just obvious this is about surfaces. Surfaces control the single slit. The distance of the separation is where you draw your vector lines from. It's just so obvious you're drawing them from the surfaces. Those are the lines that work. You want to predict the pattern correctly, you draw your line from the 2 surfaces, as if those surfaces were the sources. I mean, it's so obvious. Oh, and look at that crap. So here you have this complex pattern you're going to create with a double slit, and look what they draw. Blah, 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 blah. No double maxima. No recognition that there's two patterns. Nothing. I mean, it's just absolute crap. And that's a professor doing it? So the simple experiment, not complicated at all. You can do it at home simply. I've done it. Okay? You can make these patterns, and this is what they draw instead. And that's supposed to be credible physics. I'm just saying you can smell that right on the surface and just say, okay, they can't even draw a single element of this experiment correctly. And it's that simple an experiment. And they can't draw it correctly. That's a pretty big giveaway. That they're talking shit.
So the professor starts by explaining the setup. Electrons are fired one...
So they always switch electrons, photons, very different patterns. So again, electrons are not fired at two slits. So again, it's just another big, fat, freaking lie.
One at a time through two slits to be detected at a screen.
Doesn't happen. The only one I've even heard of where they attempted a slit experiment with electrons was inside of an electron microscope using gold to create a barrier. The problem was the electrons were going right through the gold, and it got such a tiny amount of pattern, you'd almost say it was noise more than a real pattern. And clearly it's charged. You can't get away from the fact you've charged the structure of it's inside an electron microscope. You've clearly charged the metal.
Now, because you can't say for certain which slit the particle went through, quantum mechanics tells us it must go through both. So
again, do you really believe that? I mean, you really think the discrete tiny photon lands on a surface, makes a little tiny spot, somehow goes through both the slits? So I have a slit, it's a millimeter, total millimeter from the outside surfaces, half millimeter slit openings, and the photon goes through both. It's ridiculous crap.
At the same time. So to get the probability of finding a particle somewhere on the screen, you simply add up the amplitude of the wave going through one...
So, and again, this experiment isn't done. They do get this pattern, so there's no double maxima when they do it with electrons and a crystal. And that's because the crystal is in a slit. The crystal is just bouncing off different layers in the crystal. So you have a layer here, a layer here, a layer here, a layer here. Some of the electrons hit the bottom layer and bounce off. Some of the layers hit the second layer. Some hit the first layer. And so depending on what layer they hit, they go off at a different angle. So it's a completely different experiment. This is just such a lie to present this as what happens with electrons. It doesn't. You can't even randomize an electron in the first place. So there's no way you could, shoot electrons and have a random distribution.
Slit with the amplitude of the wave going through the other slit and square it. But that's when a student raised his hand.
So this is all part of the lie story. So when it's supposed to be Richard Feynman, whose drawings are as bad as those drawings on that board. So just understand, this is the guy catching them on their bullshit, and it's not even close. Richard Feynman couldn't draw an accurate double-slit pattern to save his frickin' life. He never really... He never analyzed the true experiment because he never really took the time to figure out that it's not the woo he was taught.
What if you add a third slit? Well, you just add up the amplitudes of the waves going through each of the three slits, and you can work out the probability.
Yeah, well, it won't be the same place. So again, it doesn't make much sense that he does it in the same exact place when, no, that's when you start moving the photons, the place where they'll, all three sources will hit the same spot, okay, is when the spots start to separate. So your nodes start to separate, and you have a bunch of really dull ones, and then a very bright spot, and then all dull, and then a very bright spot. So you start expanding the pattern the more you add.
The professor wanted to continue, but then the student interjected again. What if you add a fourth slit and a fifth? The professor, who...
Now you're just talking about a diffraction gradient, which you can see does the shifting, okay? So you can see definitely the color spectrum shift, so you can understand that in a one monochromatic wavelength, it's shifting.
who is now clearly losing his patience, replies, I think it's clear to the whole class that you just add up the amplitudes from all the slits. It's the same for 6, 7, etc. But now the bold student pressed his advantage.
Oh, brother.
What if I make it infinite?
Fake story. Okay, there's no such thing. Infinite slits in what way? Infinitely small? Well, you can't go infinitely small because you know there has to be atoms to create the barrier, right? So we can't make infinitely small slits. So what are you talking about? Infinitely long, well, we know the light's not going to go infinitely across the entire infinitely long thing. Where you're going to get a flashlight or a laser beam that has an infinitely wide beam. So this whole thing doesn't make any sense at all. Too fucking silly.
Slits. So that the screen disappears.
So there's no disappearing screen. None of this crap happens. It's just absolute bullshit.
And then I add a second.
I don't even know why he's saying this crap because it doesn't make any sense at all. There's still matter in the way of the photons. They're still going to interact with the slits. They're still going to cause scatter. So it doesn't matter how many layers of it you create. It doesn't matter whether you put 2 slits behind 2 slits behind 2 slits. You're going to still end up with just 2 frickin' slits in the end. The point sources are still the same surfaces that do the ejecting to the outside world. It almost doesn't matter what you're putting in. It just matters on where the surfaces are. The last surfaces. The last surfaces win.
Screen with infinite slits, and a third, and a fourth. The student's point was clear.
No, it is. What's a clear point there somewhere? There's no clear point. It's an absolute idiocy. It's nonsense. You know, why don't you just draw a 2-headed dog on the board and say, what? Is this what you mean? What are you talking about?
Even when we're not doing a double slit experiment, when it's just light or particles traveling through empty space, they must be exploring all possible patterns.
So this is all possible patterns? This isn't even a drawing of all possible, right? What is this? This is a little bit of chaos, but it's not all possibles. So all possibles would just be a complete opaque screen covered in just complete opacancy. It's just such bullshit.
Maths, because this is exactly how the math would work if you had infinite...
Oh, the math. Okay, so just again, the math for the double slit experiment, again, is the only math that works. You draw your vectors from the surfaces, not from the center of the opening. Okay, so it's not about some stupid fucking wave. It's about the surfaces. That's the only math that gets right answers. Because the surfaces are causing the action.
Screens, each with infinite slits. You have to add up the amplitude from each slit. That's just the way it works.
No, it doesn't. It's not just the way it works. There's lots of better explanations for how it works.
According to the story, the student was Richard Feynman. And while the story is made up, the logic...
Yeah, so what's the point? So the story is made up. I'm going to tell it anyway. To aggrandize fucking Feynman, who couldn't draw an accurate description of the experiment.
Logic is flawless.
Because if you believe in a double slit experiment, that you can't tell which...
Okay, so again, if you believe in all the wooey crap they've lied about what the experiment actually does, okay, then you can fall for more stupid, idiotic stuff. But if you're a rational person and recognize that the single slit can't be making 2 waves, there's no place for the 2 waves. Where's the 2 waves coming from? I mean, Professor Lewin actually states, okay, look, you can't believe single slits are being controlled by some different mechanism than double slits. It's the same phenomenon. Whatever the mechanism is, it's the same mechanism for all of these things. You can't call the single slit diffraction and call the double slit interference. That's just plain nonsense. All right, I mean, the same double maximum, they have so many same features. There's no way you can sit there and say reasonably it's a completely different phenomenon. It's not. And again, the only math that gets the right answer for the double slit is the recognition of 4 sources, especially when the slits are open. Again, when they close the slits, when they make them smaller than a wavelength, yeah, then they've turned 2-point sources into 1-point source. If I put 2 headlights right next to each other, you can't see the 2 headlights anymore.
If the 2 slits the particle went through, then you have to consider the possibility that it goes through both.
Both. Yeah, it goes through both. No, you don't have to. There's absolutely no reason to believe that any of that crap is necessary. There's no photon going through both things and then somehow taking those particular paths. And it makes perfectly good sense to recognize that the photons are being disrupted by the surfaces. They're being broken, essentially. The frequency is being broken. And now you're just going to put them back in phase when they hit the surface. You're going to take a piece of a photon that went through slit A and hit the surface slit A. And you're going to combine it with a photon that went through slit B and hit a surface on slit B. And you're going to combine those 2 bits of energy and remake a photon.
By that same logic, anytime any particle goes from place 1 to place 2, you have to consider all the possible paths it could take to get there.
Oh, no, you don't. Why? Why would this have anything? Again, so they're just saying that the whole universe is magic. And so isn't slits aren't magic because every photon gets diffracted by the magical magic? No, it doesn't.
Including ones that go faster than the speed of light.
Okay, faster than the speed of light. Why are we indulging this argument? There's absolutely no evidence that anything's going faster than the speed of light anywhere in this universe. I mean, for him to get away with saying that kind of crap, and nobody's going to protest and say, oh, shut up. I mean, go this far, but don't go that far. I mean, this isn't Sasquatch. This is, Sasquatch with a duck's head.
Including ones that go back in time.
And just fuck. Fuck. What the fuck? This isn't science. This is such wooey shit. God damn, I just don't know how it doesn't offend you fuckers. How you're not offended that somebody's going to try to sell you this argument that somehow not only do we have faster than the speed of light motion in the universe, but somehow photons can travel back in time. They can test what happened 50 years ago or something and say, oh yeah, well something happened 50 years ago, so I'm going to do something different. And then I'm going to look at the future and see how it comes out. And if it doesn't come out well in the future, I'll do something different. I mean, this is just... Oh, this is worse than a God theory.
Including ones that go to the sun and back.
I feel like it can't go to the sun and back. You have to restrict it to be local, right?
So the math doesn't do that.
The math didn't do that. I'm sorry, but this is so bad. This is so bad. Ooh, creepy motherfucking wooey shit.
Yeah, I mean, you could see that just in the double slit experiment, right? And we'll do light, because then there's no funky business with the speed. If you're going to say, like...
There's no funny business with the speed, so somehow matter, there's a funny business with the speed, but there isn't with light. Oh, light can only go with the speed of light, but everything else can go some other speed. Oh, shit. All right, I'll take a break, but no, I can't. I just hate this planet. Fuck you, assholes. God damn it. You put up with this shit. Alright, I'm back. Shit.
This path interferes with this path, and these distances are different.
Right.
So again, he's drawing vectors. And he's drawing vectors from what location, right? Because it's not going to work if he does it through the middle of the slit. That distance won't get a right answer ever. He has to draw the vectors from the surfaces. Those are the only vectors that are going to get the correct location for the ons and offs. It has to be drawn from the surfaces.
And so clearly they can't have the same speed. So you need to consider paths.
They can't have the same speed, clearly. So he's arguing again that this idea of a frequency, okay, that somehow it must have a beginning and then a second and a third and a fourth, and that's it. And there's no way that you could take the third from one and the first from another one and have those end up at a location in the right frequency, the right time. When of course you can. So they don't understand frequency at all. They don't have any conception of what a photon is. You know, they draw this wavy shit, but they don't tell you how many of these wavy shitty things do you need to make a photon. Do you need 3, 5, 7, 10? They never even discuss the subject. Now, I'd obviously argue you need at least 2 to make a frequency. And I'd say it's probably more likely that a photon requires 3 bits of quanta to create a viable photon.
That have different speeds.
So again, he's just making shit up, okay, about some sort of speed difference. I mean, I never even heard anybody even suggest that double slit suggests that light travels at different speeds. I mean, too frickin' ridiculous.
Feynman's way of doing quantum mechanics suggests that anything going from one place to another is connected in every possible way.
So yeah, I never saw that in Feynman's lectures, frankly. So, okay, I've watched his lectures. I've read his lecture book. I don't recall him saying that, but fine. Okay, maybe later he got wooier. But as I understand it, personally, as I understand it, he said these were abstractions that work mathematically. He wasn't saying they are how the reality works, that you could borrow energy from the future, that kind of crap. I don't remember him suggesting that as an actual relevant theory. He was just suggesting that mathematically it works.
And the internet is kind of like that too, connecting us to anything.
Okay, so now he's doing his fucking commercial. Oh, God, I hate this fucking planet. NordVPN. If you want to be a good spammer, get yourself a VPN so you can hide who you are and be a scumbag.
Of doing quantum mechanics. So, according to Feynman, anytime a particle, a photon, or even a macroscopic object moves from point 1 to point 2, it has some chance to take any path. And as
All right, so just know it doesn't have any chance. It didn't do it. It doesn't think it. It doesn't feel it. It doesn't do any of this crap. It's just nonsense. And I don't know why anybody would believe the photon went over here and then went over here and went over here. Didn't like that and decided to land over here instead. I mean, it's ridiculous.
preposterous as it might sound,
Yes, it's preposterous. It's just fucking idiotic. Again, is the Holy Ghost a worse theory than this? Just tell me, honestly, do you think the Holy Ghost is worse than this? Can I pull something out of the Bible that's more preposterous than this crap? I don't think so. I mean, this is physics. This is worse than flat earthers aren't this loopy.
he found that we need to include all these paths in our calculation.
No, there's no need whatsoever. I mean, the whole clock thing is perfectly rational, okay, to recognize that it takes, at the speed of light, time for objects to move through any medium. So you just subtract from the density of the medium from the clock speed, and you just say, yes, everything is basically going through a medium in certain locations at certain amount of time. It's not that complicated. But this has nothing to do with creating curvy, bendy vectors. Nothing at all. It's a straight line. I mean, Feynman said in his own lectures, okay, it's not a wave. He said it's clumps. That's the way the machine works. The machine don't work that way. That means it doesn't collect waves. It collects clumps.
Each path is weighted the same.
So why then do we not see?
So weighted the same is again a nonsense, because in Feynman's own description he's saying it's weighted nothing, because if I have a really tiny little circle, the turning doesn't create any distance change.
All those crazy paths? Well, that's because we still need to add up their amplitudes.
For simplicity, imagine
And there's no amplitude. That's the whole point. They have no amplitude. For these irrational paths, there's zero amplitude. It'll never fucking happen.
we only have 3 paths. Then here's what we're going to do. First, let's take this one. When the particle wave starts following it, we start a stopwatch.
Yeah, so he's just doing the clock analogy. And again, the clock analogy was used to describe how light like Newton did a bunch of experiments with glass and layers of glass, and the idea is the photon keeps getting bent by the layers, okay, by the surfaces. But if you combine the surfaces, okay, so you have a medium between them, so they're all connected to each other. I'm trying to make, then you get to the whole lens argument and the distance, and the amount of distance is going to decide how much it's bent in total, blah, blah, blah. I'm trying to think of the angle at which you hit will decide how thick the glass is. That is how much you're going to get slowed down.
It goes around and around very fast, and when it gets to the end point, we hit stop. We'll do the same for the other 2 paths. And then we add up the arrows, square the result, and that is then proportional to the probability the particle took those paths to get there.
Oh, okay. So that's even taking Feynman to some extreme. That's not my understanding of his adding of vectors. Is any notion that you add up a bunch of bizarre, insane vectors that can't happen. I mean, they're not even angular. They're not even straight line vectors. I mean, everything I saw Feynman draw if a photon was a straight line vector. I never saw him draw a loopy line like this and say a photon traveled that path.
In this case, the arrow and square are pretty small, so the probability of the particle going from 1 to 2 using these paths is small.
You have to compare it to the straightest path, the most efficient one, and then that's the one that's got the highest probability. So you can't tell what the probability is by looking at one square. You have to look at the probability in relation to all the squares. So if the other square is a zillion times bigger than this, then all of a sudden this is a very low probability.
Compare that with these 3 paths, for example. Well, now the arrow is much larger. And this is important. The larger the resulting arrow, the higher the probability of that event happening.
So again, does that make any sense to you? So the more likely it is, the closer you are to the straight line, the more probable it is. But in the circumstance of actual light refraction, there's only one path that'll work, because how much the light's going to be bent happens at the surface.
Now, in these examples, the stopwatch is not actually measuring time. Instead, it measures something called the phase.
The speed of light. So the phase is the speed of light, because it's how fast is the object, the quanta moving past a location would be the argument. Obviously, they're all moving at some same speed through the same medium.
Just as in the double slit experiment, when a wave takes a different path from point 1 to 2, it will end up there with a different phase. And this phase is what determines the amplitude of the wave at that point. Mathematically, we can write the amplitude, our stopwatch, as e to the I phi, where phi is the phase.
And again, it's just, let's see how to put this. You're just talking about, this is the same as the path, the full wavelength versus less than a full wavelength of distance, and the fact that you'll be out of phase. That is, the object A will be in a wrong location to be the same distance apart, the same frequency. How else to say it? Look, Feynman concedes it's a shortcut. It's just a mathematical shortcut, this adding of the vectors. It's just a way of doing the math that's more visual, more geometric. But it doesn't change anything about the fact that you need a full wavelength is the only time you're going to have a photon that's back in phase.
As the particle wave follows a
I mean, if I have a dot, dot, dot in space and I have dot, dot, dot out of phase, you're just saying that, okay, I can't make a photon out of those two hunks of crap unless I can arrange these dots so they're in a frequency that's the same frequency between them, the same distance between them.
path, its phase increases, winding the vector around. So now the big question is, how much does the phase change for each path? Well, to answer that, imagine we split up the path into many tiny sections, each one so small that it's effectively straight. Then, in each section, the particle wave goes a distance delta x in a time delta t, and the increase in phase...
So imagine if we do something that's completely not real. Because obviously you're bending this path, so how did you bend it? And that he's not going to answer.
is easy to compute. It just depends on the wavelength and frequency of the wave. To find the total increase in phase for the whole path, we just add up all the little phase increases of all the individual sections. But we can sub in lambda equals h over mv from de Broglie, and using E equals hf, we can sub in for frequency. We can also simplify by writing h over 2 pi.
So if you know what the frequency is and you know how fast something's going, you could say, okay, here's a length of 3 miles. What's the phase going to be when it reaches that endpoint at that length, at that speed? So all you're doing is saying you're measuring how long the line is, even if it's a crooked line, and it's saying, well, it takes longer to move the crooked line. So yeah, it's going to be at a different phase than if it was a straight line. This is just such mathematical goop.
As h bar to get this expression. Then we can take delta t to the right, and if we make delta t infinitesimally small, then we can replace this sum with an integral. But now dx by dt is just velocity, so we can write this as mv squared. Now, we know that in the simplest case, the total energy E is just...
Oh, I just love that. It's back to mv squared again. So the big lie, right? They used mv squared to measure the weight of a of electron. So that's why we don't weigh our atomic weight. Because they grossly exaggerated how important the velocity was for an electron and grossly underestimated the importance of the mass. So their statement about the mass of an electron is completely ruined because they give an electron velocity and then they count the velocity as being this huge component, making up most of the energy, and therefore the mass has no capacity to be a part of the making of the energy of the electron, and so they way underestimated the mass of electrons, way undercalculated it. You really do. You're really just made out of electrons and protons. That's it. That's all there is. There isn't anything else. There's just electrons and protons. That's the only matter in the universe. There's no other matter.
Kinetic plus potential energy. And subbing that in, we're left with the integral over time of kinetic energy minus potential.
So here we are again, minus whatever potential energy is, right? This made-up potential energy idea. There's just streams. You can throw a boat in a stream, okay, and the boat will acquire energy. It didn't have any potential energy when it was sitting on the side of the shore, okay? It was just sitting there. It had nothing. It didn't have anything. Some force has to give it motion. It doesn't have motion built into it. The only real potential is storage. And so if you want to talk about stored energy, that's a whole nother subject. But they ought to be clear about the difference between stored energy and active energy. Stuff moving in circles or stuff moving back and forth is different than stuff moving linearly. It's still the same motion. It's just one doesn't go anywhere and the other does. A pendulum swinging back and forth has lots of momentum. It's stored momentum.
potential energy. But wait a second, that is just the classical action. So it's action that determines how fast the stopwatch turns.
Oh, what a pile of crap.
As the particle moves along a trajectory, its action increases, and that is what increases the phase. And what's important to note is that h bar is tiny. It's about 10 to the minus 34 joule seconds, which is way smaller than the action of any everyday object. That
Yes, because everyday objects are made of gazillions, gazillions, gazillions of interactions between electrons and protons and the force. So obviously the amount of H, okay, I can't even, on the tip of my finger, there's gazillions of interactions taking place.
means the phase of ordinary objects on ordinary paths spins around zillions of times, eventually pointing in some random direction. If you consider a slightly different path, the action may be slightly different, say 0.01 joule seconds different. That doesn't seem like much, but divide it by h bar, and the arrow will spin around 10 to the 32 more times. So again, it will just point in some random direction.
So it won't be random. So again, it's just nonsense. It's going to be very discrete. There's a real calculation there. The point is, it'll do you no good.
This is what happens to almost all of the possible paths. So when you add up the phases, they just cancel out. They destructively
Oh, what a pile of mush. They destructively interfere. So everything destructively interferes except for the one path it takes. La 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 la. Bullshit.
interfere.
The only exception is for the paths closest to the path of least action, because these paths are at a minimum. So if you make tiny changes to the path to first order, the action doesn't change.
And so for other paths that are very close to the path of least action, their arrows point in basically the same direction. They constructively interfere, and that is why those are the paths we see.
This
Bullshit. So we know that the path is dictated, okay? The mirror, everything, it's all straight line vectors. There's no frickin' other path. There's one fucking path.
explains how light knows where to go. I mean, it doesn't. It just explores all possible paths.
So you just said it again. It doesn't, but it explores all possible paths. How does it do that? What the fuck are you talking about? How does the exploring part, that information, get to the photon? So let's even just say it was possibly exploring other paths. How does it send knowledge of these other paths to the photon itself, whatever the fuck that is, without having to go faster than the speed of light? Because it's already committed. It's already moving the speed of light. Oh, it's just so ridiculous.
But the paths we end up seeing are the ones that interfere constructively. And those are the paths of least action.
So bullshit. It's just clearly a function of the matter itself. Its configuration is going to decide how much light reflects, how much light transmits. All of that's going to be decided by the texture of the surface, all kinds of things. Those are the facts that matter. None of this wooey shit does anything.
So really, this is how classical mechanics emerges from quantum mechanics.
Oh, this is class. He calls it again. So what's the point of this word classical mechanics? Again, they think 1/2 mv squared is classical mechanics when clearly it's not Newtonian mechanics, it's not Descartesian mechanics, it's not Galilean mechanics.
It's why a ball follows the trajectory it does, and how planets orbit the sun. They don't really have a precise trajectory. Instead, everything explores all.
But there's no evidence it does any of that. So yeah, what evidence is there that anything does that? That the moon is busy exploring all kinds of other paths. I mean, it's just so fucking stupid. There's clearly a force in one direction opposing a velocity in another direction that's causing it to keep its location coherent to the planet Earth, period. That's it. That's all it's doing. It's bending the path enough to keep the location the same distance.
possible paths. It's just that massive particles have large actions compared to h-bar, so that only paths extremely close to the true path of least action survive, which is why they're much more particle-like.
Oh, what a pile of shit.
If you go to much smaller particles like electrons or photons, the actions are much smaller, and so there's more of a spread in which trajectories they actually end up taking.
So again, more nonsense. It's all very, very mechanical. There's no getting around the mechanical nature of it. There is no random. There's no randomizer. Okay, there's just the fact that, yes, you can have a variable. That is, something can be hot in doing this. And so it'll cause one thing to go that way, and it'll cause something else to go that way, and the next thing go that way. But nothing's ever random.
Now, you might
Truly random.
say, I still don't believe you, but Casper has this incredible demo that
Oh, fuck.
should convince you 100% that this
100%. It should convince you 100%.
is really how the world works.
What a pile of shit.
To do it, I've got a light, a mirror, and a camera.
Right, and he's going to prove this wooey shit with a light, a camera, and a mirror, which he's not going to do.
Now, there are infinitely many paths that the light could take. And according to Feynman, we have to add up the contributions of each of them, including paths that go like this. Now, you might say he's crazy.
I'm not crazy. That's what happened. Another possibility is it could come here and go. Or it could come here and go. Or it could come where you'd like it to come and go. And it can go over here and go, and so on, and so on. And these are all possibilities.
And every
So he's going to count them as possibilities that never happen, and yet he's going to prove they happen? Oh, okay. So this is the blocking the mirror thing, I think. He's going to block certain places on the mirror and say, I don't know what he's going to say. Let's see what he says.
single one of these paths has their own little arrow. So what we can do is we can look at all those arrows and see where they line up. And so if I turn on this light, that's exactly where you see it reflect, so that the angle of incidence is equal to the angle of reflection. But now what I'm going to do is I'm going to cover up that spot so that we no longer see the light reflect. And then I'm going to prove that Feynman is right, that really light also goes like this. It's just that most of the time those effects are canceled out. Now, that sounds impossible, right? But let's zoom in.
So this isn't really an argument that some number of photons are going to hit a surface that's always going to have irregularities in it. So, you know, what angle the light is possible to get a piece of a photon to fly is, again, just like the slits are disturbing the light and causing it to go in different directions. Of course, you could have some tiny fraction of the light
To this tiny piece right here, then we see all these different paths and all the arrows just go around and around in circles. So when you add them up, they all just cancel out. But what if I cover up about half of them like so? Well, now when I add up those arrows, you suddenly do see a large resulting arrow. And so if I can somehow cover up this mirror in many, many tiny strips, then I should be able to get the light to reflect like this.
So all that's going to do, right? I mean, is there any way to do that without cutting ridges or creating a diffraction gradient? No, there's no way to do that other than to create a diffraction gradient. And we know that is going to scatter light all over the place.
And I can do that with this piece of foil right here.
There you go. So that's all he's doing. Oh, what the hell happened? Now,
As a 40
I have to fix that. All right, so it should be back. So just as I predicted, he's going to sit there and actually use a diffraction gradient, which we know is creating a whole bunch of diffraction, a bunch of spreading of the light. That's the whole way it works. That's how you can do a spectrum with it, is because it's spreading the light. So it's taking blue and putting blue, 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 red, 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 red. You know, it's creating interference patterns. So this has nothing to do with the light. It has to do with the surface you're shining the light on. So again, big fake. Classical prediction. There's no... I keep hitting the wrong buttons here. Tired. Irritated.
be able to get the light to reflect like this. And I can do that with this piece of foil right here. On this piece of foil, there are about 1,000 lines per millimeter, and that should be enough to get this effect.
So they're not just harmless lines. They're actual grooves in the material where there's 2 layers and then 1 layer, 2 layers, 1 layer. It's an actual obstruction.
So let me turn off the light.
We know that its whole point is to look through it and have it create the double slit pattern, essentially. You're causing a bunch of surfaces to cause a bunch of scatter, and you're going to create images in locations. So an image and then another image separated another image. If I created a Donald Duck, I would have a Donald Duck here and a Donald Duck here and a Donald Duck here and a Donald Duck here. So it would spread the image into more than one location, all right, because of the diffraction gradient. That's their function. So you can see it like what they'll put a star on a laser, you know, and then they shoot it through a diffraction gradient and make stars in all kinds of locations because they're using lines in both directions. I mean, this is just such bullshit to say this proves this idiotic theory that somehow a sheet of glass or a mirror is reflecting light that comes straight down over there. It's not. You can't see anything from that location. You can't see photons that way. I can't see an image that way.
Lights. So let's see. I'm gonna turn it on in 3,
Bullshit.
2, 1. We see it. We see it.
So it's just a diffraction gradient. Okay, this is a kid's toy. This is a little laser kid's toy. I mean, this is bullshit.
Ah, that is so cool. It actually looks a lot weirder than I was expecting it to. I was expecting more like one spot, but there's many, many spots where it's...
So he's expecting one spot, and he's a physicist. He's supposed to know something about physics, and he doesn't know that a diffraction film will create that. Now, so he says there's 1,000 lines. There are obviously 1,000 lines going in both directions, because, yeah, you're not going to create that pattern without lines in both directions, retard. I mean, moron. I mean, asshole. I mean, idiot.
reflecting. Ooh, okay. Okay, and just to show I haven't been cheating you.
Oh, come on. The whole thing is a cheat. I mean, you could look at the film and you could just say to yourself, from this angle, you can't even see through it. It's no longer transparent, which means it's like a diffraction gradient, or it's like a film. You know, it's like roughing up the surface of glass, and all of a sudden now all the light scatters. So a diffuser, light diffusion. So it's essentially a diffusion film right there in front of you. And he's saying, oh yeah, I haven't changed the mirror any. Yeah, no, not at all. The light's not even reflecting off the mirror.
Right underneath is my finger. And even with the light on, you know, we see the light reflect. And if we remove the cover, then what do we see? Yeah, we see exactly the normal reflection where it's always supposed to go. Which
No, you don't even have the light pointed in that direction. Like, oh, everybody agreed that was the way to think about it. Now everybody hitting it wrong. It's just complicated being me. Anyway, it's too silly.
which is right there. And then we've got now all these extra reflections, all these extra bits where the pattern just lines up. So very, very cool.
Oh, come on. Too silly. This is childish drivel. Like I say, it doesn't even have the light focused on the same spot. So how can you be making the argument that, look, the light's making the same dot in the same location when the light's not even pointed at the mirror anymore? Fuck, what bullshit.
When I was talking about this with a friend, actually, he said, yeah, but you're using a diffraction grading. That's kind of like cheating, because you get all these other reflections right now. And this light is just going in all directions. And so there's one other thing I've been super, super curious to try.
Oh, brother. It's going to get worse, I guess.
I also want to do this with a laser, where I shine the laser right next to it. And then if light does take every possible path, we should also see it come off here.
So again, what sense does this make? I mean, we already know what this thing does. That's what they use this for. That's what they use. The number one use of these stupid film is actually for this stupid laser displays where you diffract the light and you just you send an image in more than one location. Duh.
It probably shouldn't work. Actually, I have a laser right over here.
Ridiculous.
And we can see when I shine it, it really does just go to one spot. And you can see where that spot is. It's right over there, which is about the same place where we had our...
I don't even think Richard Feynman would actually make the argument that a laser beam is going to do anything other than. Okay, because there's no possibility, because it's not sending any photons over here. It can't send them over there. It's restricted. It's got metal in the way. Their photon can't go over there. I don't think Richard Feynman would give that as a reasonable argument that, yes, I shined a laser at a location, but there was a ton of photons that went in all these other directions.
Reflection. And you can also see right now, if we look at this view, that you cannot see the laser light at all, right? Like I could see the laser, but I have to bring it down all the way over here. And then I'm able to sort of see the light. But if I just put it up here, you can see the reflection. Now, what I'm going to do next is I'm going to put this foil, this magic foil, and I'm going to put it over here. Oh, and we can turn off this. And now,
so now he turned it in a different direction? I don't know. But why don't you just put the foil on the black paper and then see that it does exactly the same thing as it would do on the mirror?
Now, let's see what happens when I turn on the laser. Wait. No way. No way. It works. It works. Wait, what? Look where the laser is going. Oh my God. It actually works.
Ugh, whatever. So there's obviously a reflection. But, what is this? We can't see any of this. So this is the best they're going to do. Is say he shines the laser on the black card and somehow on the piece of foil he sees the dot. Was it reflecting off the ceiling? Yeah, come on. Too ridiculous.
What? This is definitely the coolest demo I've ever done. So what I was doing is I was holding the laser, and I can show you right now, I was shining it down like this, way off, and you could still see it reflect. But if I take this away, it disappears. And if I put this back, it appears.
Disappears from where? From where? Where are you detecting this? So this is nothing. This is bullshit.
So that shows really.
Yeah, we have one spot. So the whole point is that it's supposed to be going to all those locations, but yes, it only made one spot. Why is there only one spot? You got a whole bunch of spots before. So how come it's only one spot? Yeah, there won't be any explanation for that.
That we cannot get rid of the area which gives zero, that it really is canceling out, and if we do clever things to it, we can demonstrate the reality of the reflections from this part of the mirror.
So he's really arguing that somehow, so you have a laser that's shining light in one direction, and it's got a metal body around it, and it shoots light through a little tiny aperture, and that somehow the light is going through the sides of the laser and hitting the diffraction film in a little spot. No, that's not possible. It's a reflection of the laser.
So light, and by extension everything, really does explore all possible
Oh, this is so bad, just so bad.
paths. It's just that most of the time, the crazy paths destructively interfere. That's because the actions of nearby paths change rapidly. Now, I've studied physics for most of my life, and I feel like I never really appreciated how important action and the principle of least action are. But now I think I finally get it. And I finally get why if you ask theoretical physicists what they're working on, they'll rarely talk about energy or forces. Most of the time,
Right, exactly. They just talk about wooey bullshit when the universe is just made out of matter and force.
they'll talk about action.
Nobody in particle physics approaches particle physics from a viewpoint.
Right, and what does these particle physicists do? They just invent wacky crap that doesn't exist. Neutrinos, antimatter, all kinds of bullshit for which there's zero evidence it actually does anything ever.
Other than least action. But we teach physics historically, and least action is almost like the new kid on the block for understanding physics. And so we build up to it. But in reality, I think life's a lot easier once you realize there's this underlying principle.
Because when you do, then all you have to do is write down the correct.
I still can't believe he shines a laser and then he gets a little spot on a diffraction gradient and is arguing that somehow the laser made the little spot on the diffraction gradient the same time it was shot onto the black film. Incredible.
Lagrangian, so you get the right action, and out come the laws of physics. So you've got a separate Lagrangian for classical mechanics, for special relativity, for electrodynamics, and so on.
It's a single mathematical framework that once you've learnt it, then you can apply
MC squared. So again, it's the squared crap is everywhere. So yes, garbage, 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 garbage.
apply it in different places in exactly the same way. The hunt for the theory of everything, right? The thing that will encompass all of physics. In reality, what people are asking is, what is this Lagrangian that can spit out all of the laws of physics in this universe? That's really what they're asking.
Oh, brother. Yeah.
At the moment, we haven't really found that, right? Because we can.
It's kind of stupid, right? I mean, some equation is going to be all there is, and there isn't any more to it than this simple equation, and that's it. Because obviously the interactions have to be based on what charges are doing, and there's two different charges, electrons and protons. Clearly, I would argue protons are different than electrons in the sense they must be heavier because they get stuck in nucleuses. They're harder to move would be the obvious argument. So that's why they're stuck in the nucleus and the electrons are on the outside. Anyway, too ridiculous.
Sticky tape things together, but we don't know if that's the proper mathematical structure. So that's what people are hunting for.
Says that turd. All right, let me go back and just play this again. This silly spot on the film thing. So let's move the film over here. I just still don't understand. We don't get to see what the hell is he talking about. What he's catching over here. So from over here, he's seeing a spot on the film at the same time he's seeing a spot over here. And I'd argue that, what he's seeing is got to be a reflection off of this that's hitting this. And now he sees it because it's reflecting off of this. And let's see.
Happens when I turn on the laser.
So we don't get to see the laser. We don't get to see what he's looking at. So this stupid inset is just so useless. Because what's it an image of?
Laser.
All right, so there it is. And he's seeing two of them. So there's two spots. So he's shining on the card. And he's claiming that it's hitting the foil. And I don't know what these two spots are. So yeah, who knows? So it's just mysterious what this is an image of.
Wait. No way.
So there. So he's saying this is the card and this is the film. But there's no way to understand what the hell. So obviously to get the reflection, he has to have the camera over here to see this spot. So again, the argument would be is it's just reflecting onto the film. And then he's seeing what's reflecting off the film. It's a laser beam. Laser beams go further than just hitting. Even when they're hitting an opaque surface, they still reflect light. That's why you can see the dot on the film. It's because it obviously didn't absorb it all, did it?
No way. It works. It works. Wait, what? Look where the laser is going.
So again, it's not moving exactly like this, so I don't know. Maybe that's just their sequence is off. They don't have the film in sync.
Oh my god! It actually...
Yeah, so it's just a reflection. Guy's an idiot. He's an idiot. Okay. There's just... why, draw me a diagram of how you think that dot was put on the foil. It's not foil, really, anyway. It's film. But anyway, it's so bad. So anyway, that's what the whole thing comes down to. That's their big proof. Somehow laser beams are creating laser light in other directions that you can only see on a diffraction film. Does that make any sense? No. Why would it only be visible with a diffraction film on top of the mirror? How the hell does that make it visible? No, see, none of it's explained. They didn't give us any diagram of how the light's moving or the paths here, did they? No, so we don't know what the fuck that is. Except bullshit. Alright. Can't really analyze the defects without some, so they should have put a piece of film. Well, they can't block the camera, so, yeah, I don't know. Well, obviously. It's bullshit. Bullshit. So, till the next time, that's enough of a video. And just so bad that people fall for this crap. And so just wallow in your, being assholes. I mean, frankly, it's just the way it should be, is that all the physicists should have asshole written on their tombstone. Because, frankly, they just made up all this wooey crap. It's all unnecessary. The physical universe is not going to be... the elemental universe isn't more complicated than we are. It doesn't work that way. It gets simpler as you get simpler. Okay, not more complicated. It gets simpler. All right. Till the next time and such and so forth and whatnot.